And notice that the implementation we are going over is specific to this particular weather station. But if you want to develop your own application following the observer pattern, it would be similar. Okay. Let's first of all talk about the subject class. Okay. Just to remind you very quickly, if you see from the diagram, so for the subject class, it's really this class over here. So we'll follow the following order. We'll talk about the subjects, followed by weather data, and then we talk about observer, and then we talk about each one of the three concrete observers over here, right? That will be the order of discussing the implementation. Just keep that in mind. Also, you can have the diagram handy, so you just make sure you don't get lost. For the subject class, we got this polymorphic list of observers. Statically, it would be observer. Dynamically, it could be any of the descendant classes for observer. In this case, we got forecast, we got current conditions, and also we got statistics, right? These are the three possible dynamic tags for now. And it might be subject to extension. If you want to add more kinds of observers, it's totally possible. Okay, so the commands, notice one thing here. You can see the class subject here is simply, it's not deferred, meaning that you can declare constructor. I would say to really decide whether the subject class here should be deferred or effective, it can be up to your judgment. Okay, but just for this particular pattern over here, I'm showing to you the subject is simply just effective. However, for the observer class, it must be deferred, because otherwise you can also create simply a dynamic type of type observer, which doesn't make sense. Because you only know which observer you're talking about when you get to the descendant class level. Right? So that's why observer must be deferred. Whether the subject class must be deferred or not is up to you. Okay. So we got our linked list over here. Again, static type is list. Dynamic type is linked list. It's programming from the interface, not from the implementation design principle we are obeying. So how can we write a contract to say initially we simply just got no observers attached to this particular subject? What should be the post condition, right? So now we're going to see some exercise over here about writing contracts. We shouldn't abandon design by contract, which we exercise and learn so hard from the previous lecture and the labs. So every time when I ask you about what a contract should be, you're encouraged maybe just to pause the video before I go over the answer with you. I think that might be more beneficial for your learning. The observers should be observers.count should be equal to 0, or you can say observers dot is empty, right? We just want to say the list is simply just empty to begin with. No observer just yet. Meaning that if the subject is trying to make a change right now, and then you want to say dot notified, in that case, no observers will be notified. In that case, you'll be kind of useless because no observer is really listening to this particular subject. And then we got attach and we got detach. So what should be the precondition for attach? Well, if you want to attach, so we want to make sure there's no duplicates for the list. So if you want to attach a particular observer O, you want to make sure it doesn't exist. Well, so that should be it is not the case that observers that has O. One technical detail over here. So you can see that since we simply say we create this particular observers to be empty, and by default, the object comparison attributes for this observers will simply just be false. Meaning that when we are saying over here, observers that has O, we are really saying that this particular object by address or by reference does not exist in the observers list. This may be what we want. On the other hand, if you believe when you say has membership inquiry over here, if you want to compare the observer arguments by its content using the is equal query, maybe in that particular observer class, in that case, you should really say after this, you want to say observers dot compare objects, right? That's kind of what you learned from lab number 0. I just want to remind you quickly. So what should be the post condition? Well, apparently once you attach the observer to the subject, so that means the observer list should have that particular observer, right? So that should be quite obvious, just the opposite. You can see this one here, the precondition is exactly the logical negation of this post condition over here, right? It makes sense. And if you do detach, it will just be completely symmetric. Precondition will be the observer you're trying to detach must already be attached to the server. In that case, you want to make sure observers that has O. And after executing the implementation, what should be the post condition? You want to say, well, it should not be there anymore, right? So far, so good. What about notified? So this will be interesting. how do you notify? Assuming that you already got a list of observers attached to this particular subject. For example, if you remember this particular diagram we draw, let's say so far we have this observers list, and then we got 4 observers attached to this particular subject of observers list. So now we got 1, 2, 3, 4. If there is any change on this particular subject that we talk about, maybe subject number 1, let's say weather station, weather data. So let's say if the weather data has been updated, in that case, we want to notify 1, 2, 3, 4, 4 observers that are currently attached to the subjects. So how do we do that? Let's see. So now for the notify, we'll simply do a cross loop. We'll simply across the observers. So now I'm just using S, so that'll be a cursor. You can also use is. In that case, it will be an observer, right? So that's a subtlety we also discussed in lab number 0. So we say for every observer in the observers lists, and we're going to say cursor the item over here is going to be of type observer statically, right? And then we're going to call updates. I will try to explain this line here in a little bit more detail in just a moment. So that would be the implementation. And for the post condition, you have seen that already in the architecture diagram. So now the post condition will be after we have notified, the subject has notified any change to all the currently attached observers. We want to make sure every observer that's in the list should be up to date. So that's why we simply say across the observers again. So now we say all the item. So this will be statically observer. So now, which version of the up-to-date with subject will be called depends on the dynamic type, right? Let me just now go back to the iPad, and let's now talk about this very quickly, okay? What I would need is, maybe I will simply just make a copy of this particular diagram so we can talk about those 2 lines of code. So that'll be useful. So let me switch to, so again, this part over here, we got subjects. Okay, we're talking about the subject here. And then we talk about 2 lines for the notify. Let me just paste the diagram over here, and then I'll speak about those 2 lines again with you. Okay, let me just paste the diagram over here. Okay, that's good. Again, the observers will just be polymorphic. So now let me just enlarge that a little bit so we can concentrate on the notify. So now we talk about the notify routine or command from the subjects. You can see cursor the item over here, and also all the item, right? So these 2 are the same, have the same static type. Let's be very careful over here. So cursor the item and also all the item. So these 2 has the static type observer. How do I know it's observer statically? Because we're going across the observers over here, and also we're going over the across over here. So that means every iteration, the cursor is going to point to some objects of static type observer. I'm just looking up the definition, the declaration here from observers here. Okay, and then how is dynamic binding going to work? According to the current setup, we're going to run how many iterations? 1, 2, 3, 4. We're going to run 4 iterations. Let's just talk about the very first iteration. For the implementation over here, what's going to happen is, for the very first iteration, cursor the item is actually going to point to this particular object over here of dynamic type observer 1, let's say. And then what's going to happen is, when you call updates, it's going to call the version of updates that is specific to observer 1. But to our weather station example, this could be maybe current conditions. In that case, it's going to call the updates from current condition. Maybe for the next iteration, it's going to call the updates from statistics app, right? Hopefully you can see. That's about dynamic binding. And then one more thing. So up to date with subject here, similarly, right? So now if you recall the architecture diagram here, you can see for the updates and also for up to date with subjects, both of them are simply just deferred, meaning that each of the app classes each of them is going to implement their own version. So what does it really mean when you want to keep up to date to the subject? Depending on the app, the definition might be different. That's why they're simply just deferred over here, but they are implemented properly in the descending classes, right? It's a very common phenomenon for inheritance that we reviewed previously. Okay, so now let me just make one more note for you. It's really important to see that updates over here is the first occurrence of dynamic binding and also up to dates with the subjects. So these two will illustrate dynamic binding. Dynamic binding. At the runtime, depending on which iteration you're talking about, if you're in iteration number 1, you might be pointing to a different dynamic type than you are in iteration number 2. Depending on what the dynamic type is, the version of updates and also up to date with the subjects is going to depend on the actual dynamic type that we're talking about in the current iteration. Okay, that's dynamic binding. We're going to see how to run this loop when we see a small example test in just a moment. Okay, for the subjects, these are the again, the polymorphic collection and also how you make use of dynamic binding. That's the most important 2 points you want to keep in mind. Let's move back to the slides and go on. Okay, so now let's talk about the weather data. So now we are talking about this class over here. If you remember this diagram over here, so we just finished about the subjects. So now we talk about the weather data class, right? The descendant class of the subjects. Let's go back. So the weather data will inherit from subjects. And remember, in the subject, we actually got a constructor make, which is parameterless. There's no parameter for the make command. You can look it up in the weather data class, in the subject class. And now the reason that we want to rename, I will show you, I will illustrate to you on the iPad in just a moment. Basically, the make that's inherited from the subject does not have any parameter. However, for now, in order to really construct a weather data object, we do need to take 3 parameters: the temperature, the humidity, and also the pressure, right? So for now, we're simply just going to rename the make that's inherited from the subject into another routine called make subject. So that's a new keyword that you can feel free to use just to rename whatever features you inherit from your ancestor. You can always rename it to something that does not clash. Okay, so now, and also we're going to declare the constructor some command that we're going to add in this level here called make as a constructor. As before, we're going to have 3 attributes: temperature, humidity, and pressure. And also we need this helper routine for writing invariance. So this part here is exactly the same as in design number 1, the good bits. So I'm not going to waste your time by repeating it, by repeating them. And now for the command, you can see this make over here is actually will be considered as incompatible with the make that's inherited from the subject, because for the subject class, the make does not have any parameter, but now we do have parameters, so redefine is not going to work. I will illustrate this to you in just a moment. Okay, we're simply going to say make subjects. Let's illustrate now. Actually, let's not wait. So let's now take a look over here. Let's see. This is what I meant. Let me use blue. So look at the subject class over here and the make. You can see the make over here takes no parameter, right? There's no parameter, just make. And then what we do is we simply just create an empty observers. And we do want to make reuse this line of code in the subclass. That's what our intention. So now we got our weather data over here, the child class, and then we simply say rename the make. So the make over here is really referring to the make over here. And then we are renaming that as the make subjects. Consequently, every time when we in the context of the weather data class, whenever we talk about make subjects, we are really also referring to this particular make command. So now we already cleared up the namespace for the make in this current class. So now we can also talk about another make. So think about the make over here has nothing to do with the make over here. Not anymore. Okay. And then for the make, we simply say temperature, pressure, and also humidity. So now when we talk about make subjects, right, as we said before, the make subject is really referring to this particular make from the subject class. So now let's see why you cannot say redefine. So some of you might be thinking about, can I do the following hypothetically, right? Hypothetically, can I simply say rather than rename, I will simply say redefine the make This might be what you're thinking. I would say if you got this kind of initial thought, I would say that's pretty good. So that means you're really trying to apply what you learned previously from the inheritance lecture. If I simply redefine the make, so whatever I inherit from the make, I'm simply just going to redefine it. So now for the make over here, rather than saying make subject, I can say precursor. And now the precursor maybe is simply just referring to the make that's inherited. Okay, you might be thinking that. However, this is not going to work. Let me emphasize that, right? If you try that, it's not going to work. It's simply not going to compile. Here's the reason. Every time if you want to redefine a particular inherited command or routine, command or query, basically a routine. In that case, you must keep the original parameter list compatible. You can see that's what I meant previously. The make over here has no parameters. However, the make over here has 3 parameters. So that's why the compiler will simply just get confused. So when you say precursor over here, it's going to see that, well, when you call precursor, you're really calling this version over here without any parameters. But the current version here, you actually got 3 parameters. It's simply just not allowed. Okay, that's something I want to emphasize. That's why we're using the rename construct over here instead. Okay, so that's about the mixed subjects. Let's now go back to the slides. So the mixed subject here is just going to create empty list of observers. And then we're going to set the measurements, which is just going to initialize the temperature, humidity, and also pressure. And then we got set measurements as well whenever we want to change. And now, and then also we got the invariance over here. And the invariance over here is simply just going to use the helper routine as we said before. And now let me emphasize again, having class invariant is very, very crucial for designing your classes, because we said that in order to do modularity, we want to make sure every module or class has proper API. And API is not just restricted to signatures or declaration of your routine. You must document your routine, every one of them, with proper precondition and postcondition, and also to document your module or class with class invariant. That's very important design idea that we are trying to teach you in this course. Okay, so now let's talk about let's switch the context. Let's now talk about observer. So we're going to we are done with subject, we are done with the weather data. So now we'll talk about observer. Okay, the deferred class, which is the static type for the observers list. For the observer, we're going to have up to date with subject. Actually, the observer class is incredibly easy because the up to date with subjects and also the updates. So these two over here are simply just deferred, meaning that any effective descending classes of the observer, in this case, that would be forecast, current condition, and statistics. Let me remind you here in the diagram, right? So here you can see forecast, current conditions, and statistics. Each one of them is going to have their own version for the updates and also their own version for up to date with the subjects, right? That's something you will see once we finish talking about the observer. Okay, each effective descending class of the observer should, number one, define what weather data are required to be up to date. For example, if we talk about the forecast, right? In that case, up to date with the subject means the pressure must be up to date. And if we talk about current conditions, then the up to date with subject should be about the temperature, right? The temperature and humidity, the two information there. Okay, and also define how to update the required weather data. Well, again, if you talk about the forecast, so how do you actually update the forecast app up to date? Well, you have to link to the weather data, and then in that case, you have to make sure you actually really to get the latest read about the pressure for the forecast app, right, and etc. for current conditions and statistics. We'll see one example in just a moment, right? So now I just want you to really kind of give you kind of different pieces of the puzzle, and then we're gonna put it together in just a moment. Okay, now we'll go to the final group of classes that we're going to talk about. So now we're going to talk about basically forecast, followed by current conditions, followed by statistics, right? These are 3 concrete observer classes. Now for the forecast, it's going to inherit from observer. Every app class that's concrete is going to inherit from the observer for sure. Okay, we're gonna have a make. So this part is really worth our discussion over here. Let me switch to the iPad. We want to know how exactly do you really initialize an application objects, in this case, the forecast. How do we do that? Let me switch to the iPad and let's discuss this, okay, for the forecast. Now we want to know exactly what to write for the make, the constructor, right? We want to know what should we write in the implementation part. Let's think about what's really going to happen at the runtime in order to figure out statically what we should write at the compile time. What's going to happen is, let's think about it in this way. What's going to happen is, number one, just like in design number one, we want to make sure the weather data attributes over here, which still exist, because every time when we, even though it's on demand, but anytime we want to really keep ourselves for the forecast up to date with the subjects, you have to link to the subjects. So that means we should still have this particular link over here. So this is number one, requirement number one. So when we first create an observer objects, number one must be satisfied, right? What about number two? Number two is kind of new to the observer pattern. For the weather data, since we kind of place the responsibility of the notifying all the observers about the new change on the weather data side. So that means it should maintain a list of applications or observer. So that's exactly this particular attribute is really about. Initially, it's simply just empty. So after initializing this particular blue forecast objects, we want to make sure the first elements in the list is actually going to point to this particular forecast. You can see we got bi-directional linking over here. So we can see symmetric. The forecast application object is pointing to this particular subject. At the same time, the subject contains one of its observer being this particular forecast object. That's what we want to achieve. Let me call this number two. How do we write the lines over here to satisfy line 1 and 2? 1 should be very easy. That's what we did previously, right? Well, 1 here will simply just be, we want to say whatever argument you're passing over here is going to be assigned to the weather data attributes. So we're going to say weather data. So weather data, which is the attribute over here, is assigned to a weather data. Okay, that's number one. What about number two? Let me give you a little bit of naive thinking over here. Well, which might work, but it's not as nice. For number two, what I can say is, for number two here, the pink one, I can say maybe a weather data, in this case, is going to be WD, right? So you can imagine that when we call this particular constructor over here, this will be somehow replaced by WD somehow, right? But it's now just going to set a weather data statically. A weather data dot observers dot extend. Knowing that it's a linked list, we can say extend, for example. Extend, and then we can say extend what? What should I put over here? Well, notice that we are now in the context of the forecast over here, right? So now what should we extend? Well, if you wrote this in Java, you should know that you should really pass this. If you don't even know that, that means you have some lack of understanding for OOP, right? If you know that, you should really just put this. For example, in the case of Java, that's a good sign, but you just want to know what's the keyword for this in IFO. It's simply just current, okay? We're just going to put the current application object over here into the list. We'll say current. Okay, so this is one way to go. However, I can tell you that this is not even going to compile. Conceptually, I know what you're doing, but statically, it's not going to work. Because remember over here, if you go back to the declaration, observers is simply a list of observers, meaning that statically only the features that's related to the list that's actually statically declared in the list will be part of the expectation for observer. But if you go to eStudio and check it out, extend is actually a specific feature of the linked list, not really the list. Meaning that we can even I can show you that over here. You can see statically is actually a list. However, only the linked list actually support the extend. So you simply just cannot say observers.extend. It's simply not going to compile, right? For the reason that we explained also in the inheritance review lecture. You can only call whatever that's available on the list on the observers. That's all you can do. So this one here is not even going to compile. So what should we do? Well, I would say don't really go this way here because you're somehow wasting the code that we have already defined in the pattern. So what should we do? If you go back to the architecture diagram over here, right? If you take a look at that, so now tell me, how do we say we're going to build the list for observers? Well, we say that you're going to say either attach or detach. So that's what you can call, right? Let's go back there and then over here. So what we should say is over here, a metadata. So that is the subjects. And then we can say attach. And then what should we attach? The current application, the current forecast objects. That's what you should say. This also has the very good advantage about, because you're saying attach, you're basically encapsulating exactly how to add a new observer object like the current one into the list. Because at the runtime, this does not have to be always a linked list. Maybe later on we'll change that into a hash table. We'll change that into an array. In which case, maybe only the internal implementation for the attach has to be changed. But for the client side, we're still calling just the attach. We don't have to be affected, right? That's another the advantage for this particular design. Okay, the conclusion is you're going to see in the code number 1 and also number 2. So these two are going to make sure you have the bidirectional and symmetrical link between the subjects and also the observer. Okay, that's something you would like to understand very well. Okay, let me go back there, and then you will see that make got exactly these two lines, and then slight over here, you can either say weather data or you can say weather data because it has been assigned already. So it doesn't really matter which one you use. Okay, so I don't think it's a typo here because after this particular assignments, so both weather data and a weather data becomes alias of each other. Okay, so the post condition, of course, is to make sure they are referring to the same objects. And then the observer, okay, you can see that's for the second link. So weather data, the observer that has, so it does contain the current application forecast as the one of the observers. Okay, what about up to date with subjects? Basically, you want to say for this particular forecast, what does it really mean for that to be up to date with the subjects? Well, since we only worry about the pressure, so we have to make sure the pressure is up to date. We simply say the current pressure, now its value should be exactly the same as the weather data, the pressure. Okay, and also for the updates. So what does it really mean for the for this particular forecast to be up to date? So you can simply just go to simply go to the first design. So that's why I said same as the first design. So this part here is not changed. Now for the display, it's really important for you to realize. Remember in the first design, the main drawback is always for the display, either necessary or not, we always put the updates as the first step in the first design. But now for the second design, we don't need to do that anymore. So now why do we not need to do that anymore? Because now the forecast, the observer is completely passive. We know that every time if the subject has any change, it's going to notify us. In which case, it's going to go over all the observer and call the updates on us. In that case, we will update automatically on demand. Okay, I'm going to show you visually exactly how all the pieces of the puzzle will be put together in just a moment. Okay, so now we're going to talk about current condition. Okay, it'll be very similar. Okay, inherit from observer, and also the make will be the same to build a bidirectional link. And also now for the up to date with subjects, it's going to be defined differently, right? So what does it really mean for the current condition to be up to date? We worry about both the temperature and also the humidity, right? That's why we have to do these two checks. And then for the updates, you can also look up the implementation from design number 1. It's also the same. And notice that for the display, for the first step, we don't need to say updates anymore. So that, again, we are really doing updates only on demands. So for the display, it's guaranteed to always display the up-to-date version for the measures, for the weather data. Finally, we look at statistics. Similar, we inherit from observer, and then for the constructor, we're just going to build a symmetric links, same as the previous two. And now for up-to-date with subjects. So for the statistics app, we only worry about temperature. In that case, we just have to make sure the current temperature is the same as the latest version for weather data, right? And notice that here in the contracts, you can think about every time we're checking the contracts, we might have to involve some remote procedure call. That's okay. Contract is not meant to be efficient. It's mainly for us to really build our application with some guidance by the contract. So that's okay. As long as your implementation is efficient, that'll be sufficient. Okay, for the updates, again, you can look up to see how to do the updates for the statistics from design number 1. It's also the same. And for the display, again, you don't need to do any updates anymore explicitly. It's guaranteed to be done properly from the subject side. Okay, so that's about all the classes that we talk about. Let me just remind you, we talk about all these classes one by one already. We talk about subjects, talk about weather data, we talk about observer, and talk about each one of the concrete observer, right? So now what's really left for the observer pattern is to really put a small test and then execute it on the paper to really show you how things work together.